So I have to admit, one of the hardest videos I'm making right now is this video here. And it's hard to make it for, I guess the best analogy I can give you is when I was taking calculus in college, I had a math instructor say that mathematicians do not remember a day before they do calculus. To them, those are dark ages that have been long forgotten. And the reason is that calculus explains so much. It can be used to prove so much. And they completely forget that calculus has not been around but since the 1700s. But by golly, if you know calculus, it makes life so much easier. It's kind of the same way, is that once you learn how to draw an organic compound, I mean, you really get it. When you learn how to draw an organic compound from its formula, it's just so intuitive from there on out, and you just can't remember a day when you didn't know how to do it. And so making this video was so hard because I had to slow down and really look at my gearing. How did I figure it out? How did I know? And then how do I articulate it to you how to do this? So to draw an organic compound from its formula here, first of all, probably not going to do it. Probably going to draw it from its name. And this is the big thing about naming organic compounds, is that it's a lot easier to work with than to guess. And honestly, it's a little bit of guesswork and hand waving to make these types of formulas work. So ideally, you'd work with the name. But how do we draw it from the formula? Well, the first thing we're going to do is that we're going to look for a series of continuous carbons, because that's the way organic formulas are written. We're going to create the backbone. So we're going to look at all the carbons that are not in parentheses. So in this case, we have 1, 2, 3, 4, 5 carbons. Now, they're going to be connected in a chain, so let's go ahead and just draw that chain. 1, 2, 3, 4, 5. So we've got our first carbon, second carbon, third carbon, fourth carbon, fifth carbon. Now, the hydrogens are ignored, meaning that if we don't have anything other than the hydrogen, if we have hydrogen, we don't bother showing this diagram. We're going to use a trick though. And the trick is that each carbon is going to have 4 bonds around it when it finishes. And this is generally true for organic compounds. And this is why, yeah, we can get away with doing this little trick. So if you look at this first carbon, we have 3 hydrogens and a carbon bond, so that's 4. So this carbon here is satisfied. This carbon has the bond of this carbon, and this hydrogen. And we'll write the hydrogen, knowing we're going to ignore it. But this is only 3 bonds. And if you look at this carbon, it's bond there and there, 1, 2, and hydrogen. So we're missing a bond. How do we make up that missing bond? Well, this is your intuition here that you have a double bond. In order to generate sufficient number of bonds for carbon, in this case 4, we're going to create additional bonds between the carbons to make it satisfied. Now we have the 4. 1, 2, 3, and the 4th, the hydrogen. Now, how about this carbon? Well, we've got a bond to that carbon, and notice how we've got a 2 here. This parentheses here indicates that there is a branch, and a branch is going to be basically drawn out the way we've drawn it here. It's just that it's also attached to the carbon that it's to the right of. In this case, we have a CH group, so there's going to be a carbon and a CH3, and we've got 2 of them, so there's going to be a second one, and it's going to look like that. Now I know, went a little fast on that. How did I come to that conclusion? Well, I see 2 carbons. This is an ethyl functionality, ETHYL. So it tells me I have 2 carbons, and I know the first carbon, by the way I've drawn this, is connected to this carbon. So there's 1 CH2 CH3 group, and there's a 2 CH2 CH3 group. Now, how do I know it's all single bonds? Well, this carbon forms a bond here. It has 2 hydrogens, and it forms a bond to that carbon. So it satisfies its 4 bonds. This carbon is bound to this carbon, and it's got 3 hydrogens, so that gives me my 4 bonds. Now, last one, my CH3, it's got a bond to this carbon, that's 1, 3 hydrogens, 4 carbons, so now I've satisfied 4 bonds. So I've drawn this structure correctly from the formula if all the carbons have 4 bonds. In the case, if I had oxygen, it had 2 bonds. If I had nitrogen, it had 3 bonds. If I don't have enough bonds, I'll create double and triple bonds as needed to get them up there. Branches, off a given carbon, are indicated by parentheses. They're drawn the same way, noting that the first carbon is connected to whatever carbon it's to the right of. And again, I'm going to basically fill out any extra bonds, assume that any extra bonds in this drawing are filled out by the hydrogens. So I know that was a lot. Rewatch this video if you need to. but this is how I intuit, based on the formula like this, what the structure is. Again, we would much rather rely on the name, and this is the importance of the naming, is that it kind of gets rid of the guesswork in here. With the name, we know the longest chain, we know where things are, we know where double bonds, triple bonds are, things like that. So, again, hope this helped you.